When energy companies drill wells to produce oil and gas, they also produce tons of waste as a natural byproduct. This waste includes oily drilling fluids, flowback, and lots of other nasty refuse, and it all has to go somewhere. There are 4 primary methods that operators use to manage their energy waste. Let's take a close look at an advanced method being used by more operators every day: slurry injection. A slurry injection facility is a Class 2 UIC well that goes thousands of feet down into a permeable geologic formation. This vast underground reservoir is surrounded by impermeable rock or shale layers, creating a barrier known as a confining zone, which sequesters the waste forever. So, what is this waste? It's primarily the liquid byproducts from drilling, completion, and production processes, which are classified as RCRA-exempt non-hazardous waste streams. There are also lots of contaminants in the waste, in concentrations high enough to harm nature. So locking all of this deep underground is the safest place to put it. Now, how does an injection well come to be? The first step is choosing a location that's above the right geology and close to oil and gas drilling or production sites. The well is drilled to target depth, and multiple layers of steel casing are cemented in place to create a protective barrier between the wellbore and groundwater and other strata. Surface equipment is installed, and the injection well opens for business. Waste is transported from surrounding rig sites in vacuum and liquid storage trucks. The surface equipment extracts any non-injectable solids, then the waste is processed, blended with flowback and produced wastewater, and injected downhole. This includes solids and slurries that can't be sequestered through traditional saltwater injection methods. The fact is, slurry injection is the superior waste management solution in every way, especially compared to common methods like reserve pits and land application. Those methods use up lots of land. They're loosely regulated, unmonitored, and risky. They threaten to contaminate soil and water, and they constantly emit greenhouse gases. By contrast, slurry injection wells have a minimal footprint. They're highly regulated and actively maintained. There are very low risks and liabilities for environmental contamination. And they allow operators to handle waste responsibly while achieving net negative carbon emissions through permanent sequestration to help reduce their carbon footprint. All this at about the same cost as other methods. It's time to clean up energy.